Today we're going to look a little bit more at this exponential functions. Now last time we talked about that A is your y-intercept. It is. It is also going to be your initial amount. It is the value when x is 0. So in real life situations, that is your initial amount. Now the B is actually what we're multiplying by. It's called the growth or decay factor. So in layman's terms, that's what we're multiplying by. Now, if what we're multiplying by is greater than 1, we're going to be getting bigger and bigger and bigger. That is considered growth. Now, if it is between 0 and 1, that is considered decay. Think about it. If you're multiplying by a half or by a fourth, you're going to be going down every time. What I want to practice here is using a table and seeing if we can write the equation of it. All right. So first, is it exponential? Are we multiplying by the same thing each time? So one way we can figure it out, that is divide. 1 divided by 6, is that the same as 6 divided by 36? It is. We're multiplying by 1/6 each time. I know your mind automatically thinks dividing by 6, but we want to know what we're multiplying by. So, if I was going to write this equation, y-intercept or initial amount is when x is 0, so that's 36, multiplying by 1/6 each time, and that'd be to the x. 1/6 each time, and we can tell that it is decaying or decreasing each time. That's another way to say decaying. Let's try another one. Are we multiplying by the same thing each time? That's going to tell us if it's exponential or not. Times 2, times 2. We are. So I know it is exponential. Y equals, wait, I don't have the 0. I need the y-intercept, that initial amount. So if going this way we're multiplying by 2 each time, then the opposite way would be to divide by 2. That means that this missing part would have to be a 3. Multiplying by 2 each time, that gives me y equals 3 times 2 to the x. This would definitely be a growth. Now let's see if we can spot some from just the function. We have a fraction. That automatically means that we have decay, right? Oh no. 3/2 is bigger than 1. So this has got to be growth. Whoops. That is bigger than 1, so it's got to be growth, right? Uh-oh. A negative exponent. 2 to the negative x. Now let's really think about that. 2 to the negative x, let me go off to the side. 2 to the negative x would be the same as 1 over 2 to the x. Or, wouldn't that be the same as 1/2 to the x? It would. I really want you to think about that. because 1 to any power is always going to be 1. So if we have that negative exponent, that really tells us to flip it. Whoops, to the positive. That would be, I'm losing my mind here, decay. So let's say, what if it had been 2/3 to the negative x? Well, we can rewrite that as 3/2 to the positive x, and that would be growth.